KiCad comes with a huge library of symbols and footprints, but what if you can't find what you're looking for? Let's make a custom footprint, symbol and 3D model right after this quick plug for the channel sponsor PCBWay. Do you like PCBs? Do you want to make a PCB in a weird and wacky colour like purple? Maybe you'd like a flexible PCB. Or maybe you'd like someone to do some CNC work for you. Check out the link to PCBWay in the description. I'm doing a project with these LED filaments. I've measured them up and the body of the filament is 33mm long with a 2.5mm diameter. The leads are about 4mm long, giving us a total length of 41mm. To create a new footprint in KiCad, we click on the footprint editor icon. I'm going to create a new library for my footprints, so let's create a new library and we'll call it LED filaments. Once that's done, we just right-click and create a new footprint. So we'll call this LED filament 41mm. I'll just move these auto-generated bits of text out the way slightly and then add a rectangle for the filament body. I don't actually want this to show up in my final PCB, so instead of using a silkscreen layer, I'll use a user drawing layer. To make sure it's nicely centered, I'm going to edit the numbers directly instead of trying to draw it freehand. We now need to add two pads. I'm going to need one for positive and one for negative. Once again, I'm going to adjust the numbers to get them exactly where I want them and the size I want. So we'll do this for both pads. So this is the negative pad and that's done. So that's pretty much it for what we need for my LED filament, but what I really want is a 3D model to go with it. So let's jump into Fusion 360 and knock one up. Adding a 3D model will also let me check that everything lines up. As always in Fusion 360, we start off with a sketch. I'll make one for the connectors that stretches the whole length of the device and just extrude it by a very small amount. To position the body of the filament in the correct place, I'm creating an offset plane from each end of the connector. I can now create a sketch on one of these planes with a circle of the required diameter. We can then just extrude this to the other plane and that's our body. I'm creating it as a new body so that I can apply appearance to it, and we just need to do a quick bevel so it looks nice. Now we just need to apply some appearances. For the connector, I'm going to use some polished aluminium. And then for the actual body, I'm going to use a glossy yellow. So that looks pretty good. We can now export this as a step file and head back into KiCad to assign it to our footprint. So we load up our step file and now we can preview it here. Now having a look at this, I think I'm going to move the pads out by just maybe 0.5 millimeter, just to give a bit more space for soldering. So if we go back and adjust the pads, we can just use the numbers to do that, so 19.5 and 19.5 on this one as well. So if we now check our 3D model, I feel it looks a bit better and there's more room to get the soldering iron in. So with that done, let's create the symbol. So we go back to the main screen of KiCad and click on the symbol editor. Once again, I'm going to create a new library to hold my symbols. So we'll click New Library and I'll call it LED Filaments. And with that done, we right click and create new symbol. So let's do LED Filament 41mm. I'll just move this text out the way and then we'll design some nice graphics for our LED filament. So I'm going to draw a bunch of LEDs just to indicate there's multiple LEDs in this package. So we'll draw one and then make a bunch of copies. And that looks pretty nice. We'll just put a box around it so that it encapsulates the whole component. So now we just need to add our pins. So we need a pin for the positive connection. One thing you do have to remember is to set the pin number. If you don't do this, then it won't connect up to the footprint properly. So that's the positive connection. And now we just need to add the negative connection. And with the final bit of tweaking of positions, we're done with our symbol. So let's try it out. I've started a new schematic. Let's make a 7-segment display. So I'll add in 7 of our new LED filaments, and I'll just arrange them in a particular pattern for a 7-segment display. So I've added all 7. I'm going to use a common anode, so all the positive pins will be connected together, and I'll be switching on the negative pins. I'll add in a pin header for all the connections, and I'll use labels to connect everything together. This will just make the schematic slightly easier to read, as there won't be wires going everywhere. So that's it all wired up. We now need to assign the footprints. So we click the Assign Footprints. KiCad will prompt us to annotate the schematic, so that just adds numbers where you currently see question marks. So if we select all the LED filaments and then we search for our custom footprint, we just need to double click on it and that will assign it to our symbol. And now we just need the footprint for our header. I'm going to use a horizontal header because I'm going to plug these PCBs into a motherboard. So that's that done. Let's design the PCB for this. So we switch over to the PCB tool and we update it from the schematic. So that's added our components to the PCB. I'll position them in approximately the correct position. So that's done, and if we look at the 3D preview, we can see our nice LED filament model is being pulled in. But I want quite a complex board outline for my project. I've designed how I want it to look in Fusion 360. But if you look at the underlying sketch for the board outline, you can see that it's pretty complex with lots of construction lines. We can't use this board outline in KiCad. But what we can do is create a new sketch and we can project the board geometry onto it. This will give us a really nice clean sketch that we can export as a DXF file and then import directly into KiCad as our edge cuts. So let's export this as a DXF file. So I've turned off everything else. You can see it's nice and clean. So we right click and we do Save as DXF. So then back in KiCad, we can import this as graphics and set it as the edge cuts layer. So we just need to rotate it, and then we'll just tweak all the positions so they line up nicely with our new board outline. So that's done. Let's look at the 3D model. So I think this is going to look pretty cool. I just hope it can actually be manufactured, but we'll see when we send it off for processing. So I finished all the routing. We do have some design rule warnings from the connector, as it has a bunch of silkscreen that we don't need that overlaps the edge cuts. So what we can do is we can go in and edit the footprint and remove all of this stuff we don't need. So we go and update the footprint, and now we can just delete the bits that we don't want. Now, one thing to remember is this only affects the footprint in this PCB. It's not going to affect the global footprint. So now, when we run the DRC again, all of our warnings have disappeared. There's just a final bit of cleanup to do and adding some pin labels. I've hidden all the user graphics and it looks very nice, and the 3D model looks great as well. So these PCBs are going to plug into my main control board, so I might make a custom symbol footprint and 3D model for them later. I hope you enjoyed this video. If there's anything in my workflow that could be better or is just plain wrong, then let me know in the comments. I am still learning KiCad 6, so any advice would be much appreciated. I'll see you all in the next video.